Hello and welcome to Maths Table. In this lesson of Algebra section 1.2, we're going to discuss how can we add or subtract different terms of an algebraic expression and how to expand an expression using distributive law. First, let's check out algebraic addition. Before we go into more details, let us first ask a few questions like, can we add a length into another length? Well, any common man will say yes, we can. And what do we get as a result? We'll say we'll get another length or total length, such as if we add 3 meters into 4 meters, we'll get 7 meters. And similarly, if we need to add an area into another area, like 1 square meter into 2 square meter, we know that we'll get another area of 3 square meter. But can we add a length into an area? What do we call the final result? Like 3 meters plus 1 square meter is equal to what? 4 meters or 4 square meter? Well, the simple answer to this is none of these. This is because the length and area are quantities of entirely different nature, of different types. We cannot add length into an area. This doesn't make any sense. And this is something very common. So we can simply conclude that we can only add or subtract those quantities which are of the similar nature. Now we can extend this same ideology into algebraic addition. Now in algebra, we use letters, alphabetical letters A, B, C, X, Y, Z instead of length, area. Such as, for example, if we take this square, we have denoted the length of each side of this square by X as centimeters. And since X represents the length of each side, then the area of this square will be equal to the product of the length into width, which gives us X square centimeter square. Now here we can see that X and X square are two different variables now. And based on the nature of the sum of two different quantities, we have concluded that we cannot add two different quantities into one another. So what if we are asked to add x into another x? If we add 5 meters into 5 meters, then we know that we'll get 2 times 5 meters, which is 10 meters. So similarly, if we want to add a length of x centimeters into another length of x centimeter, equal length, we know that we'll get twice the same length. And since x represent these two x represents length of the sides, and we can add a length into another length, so these two variable terms are called like terms, and it is possible to add or subtract two terms containing the same variable, since the same variable means the same quantities in the real world. So as we can add length into length, so we can add x into x. But can we add x into an x square? We have already seen that x square means the area, and we have concluded that we cannot add a length into an area. Since in algebraic expression we translate these real world quantities into alphabetical letters, and since in the real world length and area cannot be added into each other, so that is why we can say that x and x square, these different variables represent different nature, and hence they are unlike terms. So it is not possible to add x into an x square because x means length and x square means the area. So we can conclude that in algebra we can only add or subtract terms containing exactly the same variable or like terms. For example, 6y minus 4y contain the same variable y, and in the same variable we can simply add or subtract their coefficients. So 6 minus 4 is equal to 2y. So this is what is all about algebraic addition. Now, in the next section, we are going to discuss expansion of algebraic expressions. Now, expansion simply means that if an expression is written in the form of brackets, just like here, we have 3 times a minus b, we just need to open up these brackets and hence obtain a complete expanded form of the expression. So if we need to expand this expression, we can recall from the definition of multiplication that Multiplication is the addition of same numbers. So 3 times a minus b simply means that we have to write a minus b 3 times and we need to add all these brackets together. Now, if we recall from the previous section that we can combine all the like terms together in an expression. So here we have 3a's which are alike and 3 - b's which are alike. And based on this positive sign, we can add these 3a's to get 3a and 3 - b's to get minus 3b. This process of combining the like terms together is also known as simplifying process. So, however, we can also apply another way of doing that, which is called the distributive law. Now, in the distributive law, what we do is we simply multiply the number which is outside the bracket with every term inside the bracket. Hence, we distribute this number 3 with all the terms inside the bracket. So that's why it's called distributive law. So doing that, we get 3 times a plus 3 times negative b. Now carrying out this calculation, we get 3a minus 3b, the same answer like we obtained in the previous calculation. So this is how the distributive law makes it much easier for us to expand an algebraic expression. Now what happens if we have another bracket in place of this 3, such as here we have to multiply two brackets together? Well, the process is still very simple, but with one extra step. What we need to do is we need to select one term of the first bracket at a time and then multiply with the second bracket in the same way. So doing that, we'll first select the first term of the first bracket and multiply with the second bracket, and then we'll select the second term of the first bracket and multiply with the second bracket again. So doing that, we can open up now using the same distributive law. Then we get x times x squared plus 5x plus 2x plus 2 5s are 10. Now in the final step, we have to check that do we have any like terms in this expression? We do have these two terms containing x. So we can combine these two terms easily by adding their coefficients together. So 5 plus 2 means 7. Hence we get x squared plus 7x plus 10. So this is how we obtain the final simplified version of the expansion of these brackets. Now let's check another example. Suppose that we have to simplify this expression 13 minus x plus 7 times x minus 4. Now this expression can become a bit tricky to expand because of this minus sign. Because when we multiply the two terms inside the brackets and again with the negative sign, we may get an error due to this negative sign. So the best way to do is first separate the minus sign by placing extra brackets, like these extra square brackets. Now in the brackets, we can see that we have a similar question just like we did in the previous slide. So we can apply the same way. We can first solve the expression inside the bracket, leaving this 13 and minus sign apart. So doing that and expanding using distributive law, we get x squared minus 4x plus 7x minus 28. Now these two terms, minus 4x and 7x, are alike, so we can combine them by adding minus 4 and plus 7. Hence we get x squared plus 3x minus 28. Now finally, as we have now obtained the simplified version of the expression inside the bracket, we can now open up this bracket by simply multiplying every term of the bracket with minus 1 outside. So opening up, we get 13 minus x squared, minus into plus minus 3x, and minus minus plus 28. Now in the final step, we can see that we have two constants, 13 and 28. So we can combine these two constants together to obtain the final answer, x minus x squared minus 3x plus 41. So this is how we can easily apply distributive law to obtain an expansion and hence apply the algebraic rules of addition to combine the like terms together and obtain a simplified version of this expression. Lastly, we would like to thank you very much for your valuable time in watching this video. Please subscribe to our YouTube channel and follow us on Instagram if you want to talk to us directly. Thank you very much and have a nice day.